Okay, hi, so welcome to this video where we're going to talk about density, right? We're going to discuss what density is, what affects it, and in the lab, so you can do this at school, how you actually measure density. Alright, first of all, you probably already know the formula for density, and that is that density is equal to mass divided by volume, right? Very, very simple, and that's absolutely true. However, if we're talking about particles, right, if you've seen my previous video on particle theory, then you know what I'm talking about. If not, then please do go and have a look. If we're talking about particles, okay, the density of a substance really depends on two things, okay? So number one, it depends on the mass or the size, okay, of particles. Right, so for example, an atom of hydrogen is not the same as an atom of gold, right? An atom of gold is bigger, it's got a higher mass, right? And so the particles are actually heavier. Yep. Two, it depends on the arrangement, okay? The arrangement of those particles. Okay, what I mean by that is if the particles are spaced out quite far away, then the density is going to be lower than if they're all really, really packed tightly together. Okay, let me show you what I mean in a quick diagram. Okay, let's say that you had a substance where you had particles which are spaced like this. Okay, right, that's within a certain volume. Okay, let's just say that this square is at certain volume, whatever. Right, you see the particles are small. I'm trying to represent here that the particles don't weigh a lot, so they've got a small mass, and there's a lot of space in between them. Okay, now if you had another substance where in a given volume you had heavier particles really tightly packed together, right, etc., etc., etc. Okay, should look something like that. There we go. Now, which one of those is going to have a higher density? Well, of course, it's going to be the one on the right. Okay, you've got a larger mass. Okay, and they're more tightly packed together, right? And that's what we're talking about in terms of particles. A denser substance has particles packed closely together, and those particles themselves are actually heavier, got a higher mass. Alright, now you need to know how, in the lab, we actually measure the density of different substances. Okay, and it's a different, it's a different method that you use for solids and liquids. Okay, so let's go down. Now, we're first going to have a look at solids. Okay, now, the simplest way that you measure the density of a solid is if you have a perfect regular solid. Okay, so let's say regular solids. Regular solids. For example, a cube. Yeah, so e.g. cube. Right, a cube looks something like, but way better drawn, this. Right, I've never been an artist, so excuse that drawing. This is meant to be somewhat 3D. Right, so let's say that that's a cube. Now what you do is you just measure the length, the width, and the height, and you multiply them. Right, you can physically calculate the volume. Okay, so you can calculate the volume. I'm going to type this actually so it's a bit smaller. Yeah, so calculate the volume via measurements. Okay, then what you do is you measure the mass on a set of scales. Okay, all you need to do is mass divided by volume equals density, and you just need to make sure, so you need to be careful that the units are the same, right? In another video, we'll go through example calculations for you, okay? But just one thing to look out for is the units. They must agree. So you can't use density as kilograms per centimeter cubed and then mass as grams because they don't, they're not the same. All right. But what about irregular solids? Okay, irregular solids. Okay. Now, an irregular solid is one which you can't just measure the dimensions and work out the volume, right? It might be a rock. Now, a rock's got loads of jagged edges and stuff, and so it's impossible to work out the volume just by simple calculation. Now, what you do is you use a set of apparatus, one of which is called a Eureka Can. right? Let's have a look at this diagram. Okay, now this here is a Eureka Can. Let me just change color. The Eureka Can is this one, and you see how it's filled up with water. Okay, this is meant to be water, right to the top, and then you've got this spout coming out, and here you've just got a measuring cylinder. Okay, sorry for the bad handwriting. So you've got a measuring cylinder here. Now let's say we had a rock, right, which for whatever reason is red. Okay, and it looks like that. What you do is you pick up the rock. This is after filling up the Eureka Can with water, and you drop it in. Plop. Now what happens is the water level rises. Okay, it rises by the volume of the rock. Okay, so this rises up, rises up, rises up, and some water trickles down that spout and into your measuring cylinder, right, up to a certain volume, might be there. Okay, now once that has actually happened, what you do is you record the volume of the water. Okay, and the volume of the water in the measuring cylinder is the volume of the solid. Okay, so let me just type that out for you. Fill up Eureka Can with water. Okay, add solid to can and measure the volume of water which is displaced into the measuring cylinder. Okay, and that's what you do, and that volume is the volume of your solid, and that is you done. Now finally, we have liquids, right? So if you want to measure the volume of a liquid, okay, let's just move this. This is our apparatus. Okay, so you've got your measure or your scales. Okay, this is measuring your mass. Okay, and then here you have the measuring cylinder as before. Yeah, I'm just going to put measuring cylinder. Now what you do is you take your liquid, whatever it is that you're trying to measure the density of, okay, and you pour it in. Yeah, and you pour it in at regular intervals. That might be at 10 milliliters. Then what you do is you record the mass. Sorry, let me go back a step. First of all, what you do is you zero your scales with the measuring cylinder on top of them. Okay, that means that while the measuring cylinder's on top of them, they'll show no mass. And so whenever you pour your liquid in, it's only measuring the mass of the liquid. Okay, that's the first step you want to take. Then when you pour your 10 milliliters in, you record the mass and you write it down. Right? Then you pour another one in. Right? You keep pouring liquid on top. So that's gone. That's 20 mils. And then you record the mass of that. And then you keep doing that. So then you'd add another 10 mils, right? And so that's 30, you record that mass, etc., etc. Right? And you keep doing it, keep recording the mass of your new volumes. Okay? So there's a reason for that. I'll tell you that in a second. So I'll just type down the steps. So add measuring cylinder to scales and zero the scales. Right? That's important, so we're only measuring the mass of our liquid. Add liquid at regular intervals. Okay, and by intervals I don't mean time intervals, I mean volume intervals. Yeah, for example, 10 milliliters. Yeah, and record mass each time. Yep. Then when we have a mass for each volume, we calculate, let me just move this actually because that's going to get in the way. There we go. We calculate the density at each volume. Then we take an average of the densities to give us our final answer. Okay, now ideally each time you take a reading and then you calculate the density at each reading, you should get the same density, right? But that's only if you did this perfectly. Okay, it's very unreasonable to think that you're going to do it perfectly, because if you're reading off a measuring cylinder, there's some error in your reading. right? You're going to be looking at it, but you might not have added exactly 10 milliliters. It might have been 10.5, might have been 11, who knows, right? But you're trying to get it correct each time. So you're trying to hit the 10 mark, and then you're trying to hit the 20 mark, etc., etc. And there's going to be some error in each. Yep. But if you take multiple readings and then you average them, then the whole point of that is to reduce the error in your final answer. Okay, rather than just pouring in one volume, taking one reading and then working out the density. Yep, you're pouring in your volumes, there's error in that, taking the mass and working out the density at a load of different stages, and then hopefully your average is going to be closer to the real value. So that's just all about reducing error. Okay, all right, now I'm going to stop there. I hope that made sense. You need to know about those practicals, how to find the density of a solid and a liquid, right? Whether it be a regular solid or an irregular solid. Your irregular solid, obviously, you just find the volume and then you do the mass divided by that volume, etc., etc. Okay, so I hope that did make sense. If there's anything which is still unclear, then as usual, please feel free to put it in the comment box below or send me a direct email using the link. But please do like and subscribe because it always does help me out, and you'll be notified of new videos when they become available. But thanks for watching, and I look forward to seeing you in the next one.